This is not a traditional video game, and these aren't your regular NPCs. Each character you see on the screen right now is actually an AI agent pretending to be a historical figure. Plato, Aristotle, Turing, all of them are simulated by a complex agentic backend. A simulation where ancient philosophy meets modern AI. In this practical course, you will build an AI agent simulation engine that brings historical philosophers to life in an interactive game environment. Imagine having deep conversations with Plato, debating ethics with Aristotle, or even discussing artificial intelligence with Turing himself. And all of this while you learn how to build AI systems that actually work. Ladies and gentlemen, welcome to the Neural Maze. Hello friends, welcome to PhiloAgents. As far as I know, the first open source course that teaches you how to connect a video game with an agentic backend. During this course, you will learn how to build advanced RAG systems, how to ship agentic workflows or RESTful APIs, how to apply LLM ops and software engineering good practices, and also how to use industry tools like ROC, LangGraph, MongoDB, or OPIC. Of course, by the end of the course, you will have your own game simulation powered by AI, running locally on your laptop. Each lesson is divided into a Substack article and a video, like the one you are watching right now. And you have all the code available in the Neural Maze organization. Before I begin, I want to introduce you to my teammate, Iusztin, who co-created this project with me. He is the creator of Decoding ML, an educational hub that teaches you how to build real-world AI systems. Apart from that, he's also the author of a technical book called LLM Engineer's Handbook, which, by the way, is a bestseller. I will leave a link to both his Substack and also the book in the video description. We have put a lot of effort into this project, and we hope you are as excited about it as we are. So if you're ready, let's get started. Hey guys, welcome to lesson 1 of PhiloAgents. In this first lesson, I'm just going to give you a very high-level overview of the architecture and all the tech stack that we will be using throughout these 6 lessons. But before I begin, I want to give you a quick introduction to the 5 additional lessons that we'll be covering in the next 5 weeks. Lesson 2 is going to be about creating a PhiloAgent. This is the name of the philosopher agents that we have created. And we are going to create these PhiloAgents with LangGraph. LangGraph is going to be the agentic framework that we are going to use to generate all the agentic workflows. Okay, in lesson 3, we are going to cover the memory system. As you remember from my previous videos where we implemented this WhatsApp agent, we used SQLite and Qdrant for creating these memory systems. In this course, we chose to use MongoDB as the memory system. We are going to store both the short-term memory and the long-term memory in this popular database. In lesson 4, we are going to cover the agentic API implementation. All right, that is, we are going to take all the agentic workflow and expose this agentic backend from a fast API application. And we are going to also implement WebSocket, which is going to be really cool because this provides a very good way for the communication, the real-time communication between the video game and the agentic backend. Okay, we are going to cover WebSocket, as I was saying. In lesson 5, we are going to evaluate agents, that is prompt monitoring, prompt versioning, and observability using OPIC for that. And in lesson 6, we will see how everything works together, how all the different pieces work together in this multi-agent simulation. Alright, so now let's go to the next slide, where we have this high-level architecture that I believe simplifies a lot the understanding. Okay, so let's start isolating different components here. You can see in yellow here, this rectangle in yellow. This signifies that it's the online part, all right? This rectangle is encapsulating all the different components that belong to the online phase of the PhiloAgents project, okay? The online phase is basically the moment where you start interacting, you start playing the video game, and you start interacting with the agents in real time, all right? But then we have an offline phase, all the things that are outside this rectangle, all right? So we have all of these data sources, this generate eval dataset, etc. We are going to focus, first of all, in this offline phase. So this RAG feature pipeline that you see in here is necessary because we are creating philosophers, and every philosopher, every thinker, Turing, Ada Lovelace, Socrates, Aristotle, they have a very specific context, a very specific way of seeing the world. For example, Plato will believe in some ideal forms, or Socrates will believe that there is an ideal justice. Turing will be focused on the Turing test and the Turing machine and how to explain computation. So all of this information, all of this context is going to be fetched, is going to be retrieved from Wikipedia and also from the Stanford Encyclopedia of Philosophy, which is one of the top authorities when it comes to philosophers and thinkers. All right, we are going to retrieve all of this data, all the relevant information for each one of the philosophers from Wikipedia and from the Stanford Encyclopedia of Philosophy, and we are going to store that into MongoDB, that is, into this long-term memory. All right, going to take all of this information. We are going to transform this information into embeddings and just put everything into the long-term memory, all right? Because then, during the online phase, we will be retrieving information from this MongoDB instance. Perfect. Of course, this is something that we are going to cover in much more detail in lesson 3 when we cover the memory systems, but just to give you a very high-level overview. All right, so that's exactly the goal of this RAG feature pipeline, all right? That creates this vector index inside the long-term memory. All right. This generate eval dataset is also very important because, as you might know, many people build RAG systems, but only a few are evaluating these RAG systems. And we need this generate eval dataset for that exactly. We need to create a set of questions for Plato, a set of questions for Socrates to really be sure that our RAG system is working as expected, all right? And this is something that we are also going to cover in lesson 4 when we talk about observability, pro-monitoring, and evaluation, all right? Perfect. You can see, by the way, here that OPIC is mentioned because we are going to treat all the evaluation, all the pro-monitoring, etc., the observability with this amazing tool, OPIC, and MongoDB that I have already mentioned. So for the online phase, what you need to understand is that we have two main components interacting with each other, all right? We have a game UI. This is implemented using Phaser. Phaser is a framework, a JavaScript framework that lets you create or implement video games that are running in the browser, all right? Like in Google Chrome or whatever. And that's exactly what we have built. We have built an interface, the PhiloAgents town that you saw at the beginning of this video, with Phaser 3. And that's this module that you see here, this game UI, all right? And when you interact with any of these philosophers inside the game UI, you are going to interact under the hood with this agent inference pipeline or agent backend, all right? So let's see what are the different components that build up this agent backend. So first of all, we have this fast API server. This is the API that Phaser is going to interact with when you start talking with a philosopher. Then the fast API server is going to connect with the agentic layer that you can see here, that connects all the LangGraph related code that defines the agent workflow. All right. And the agentic layer is going to connect as well with everything related to the state client. This means the graph state client, okay, that it's going to be persisted inside the short-term memory in MongoDB. the retrieval tool. This is necessary to retrieve the information that we have previously stored using the RAG feature pipeline. Prompt management, we have a lot of different prompts that we also need to version, we also need to use inside the agentic layer. For example, the character prompt, the summarization prompt, etc. And then the LLM gateway. And in this case, we are using Grok as the LLM provider, as you can see right here. In particular, we are using Llama 3.3 70 billion for all the interactions that you see inside the game UI. And we believe Grok is a very good choice because it provides a very generous offer in terms of the number of tokens that you can use. And and it's great that you can be using powerful LLMs like Llama 3.3 70 billions for free. I mean, that's amazing. Okay, and I think that's basically it for this general introduction to the architecture. Now I'm going to show you one last slide where I'm going to give you an additional way of looking into this. So here you can see that there are three main components, and then the LLM API. This is the LLM provider. We have the server, we have the memory, and we have the game UI, all right? So what's going to happen? Let's follow the numbers here. So we have here 1. Suppose that you or Sophia, we call the character Sophia because it makes sense, we think. And she's speaking, or you are speaking with Turing, all right? So when you send one message, when you say to Turing, hey, how are you? I know you are Turing. Pretty cool idea, you know, the machine, the Turing test stuff. All right, so what's happening is that this question, let's follow the path of the question, is going to reach the agentic layer. And in here, we are going to, let's move to the previous one. It's going to pass through the fast API server, the agentic layer, and with all the LangGraph workflow that we have implemented and that you will see in lesson 2, we are going to provide an answer, all right? Of course, here in 6, this agent is going to make use of a tool in case the agent needs it. If we are asking about a specific topic of Turing's context, like for example, hey, tell me everything you know about the Turing test or the Turing machine. In that case, it will make use of this tool right here. And it will take all of that information from the long-term memory, all right? Because remember that we stored all the context about Turing as embeddings inside the vector database, MongoDB, the vector search capabilities of MongoDB. Perfect. After that, after the agent has processed all of the information and generates a response, the response is going to be sent back to the game UI. And that's exactly what you will see as Turing responding, all right? We think both this architecture, this diagram, and this diagram make a good introduction to what we are going to build. So now that you have a mental map of what we are going to build, I think it is time to move into the repository. I will show you how to clone the repo, although that's trivial, and how to set up everything to have your own PhiloAgent simulation running locally. So let's go. All right, so you need to go to the Neural Maze organization in GitHub. And in there, you need to look for this repository PhiloAgents course that you can see right here, PhiloAgents course. So you get inside. And what I'm going to do, first of all, is just to clone this repo. So yeah, let's open a terminal here and let's go to desktop, for example, and simply clone the repository. And now let's get into a repository, and we are going to open a cursor IDE, but you can use whatever IDE you want. So let's get inside. It's called PhiloAgents course. Okay, and now we are opening cursor in this folder. All right, so when this is ready, okay, let me put the cursor tab here. All right, perfect. You will see something like this. You have the VS Code with all the parameters, and then 2 core components that are basically the PhiloAgents API, that is the agent backend that I've been covering in the previous slides, and also the PhiloAgents UI that contains the game UI. if you get inside the PhiloAgents UI, for example, you will see that it is in itself a phaser project containing a lot of code related to the classes, the different classes that are going to be part of the game UI, the scenes, all the different scenes like the game scene, the main menu scene, etc. Everything in JavaScript, and all the different services for the API connection with the agentic backend. All right. This is for regular HTTP requests, and this is for the WebSocket connection that we are going to cover when we implement all the Fast API application. All right. Let me know if you want some deep dive inside this JavaScript code, because our main idea, our initial idea was that this course is for AI engineers and ML engineers that want to understand way better how to implement agent applications, real-world agent applications. So we thought that we could take for granted all the JavaScript code. But of course, if you want some bonus lesson where I explain all the different classes and all the JavaScript code that I have implemented, then let me know in the comments, and of course I can do it. But yeah, this is the PhiloAgents API UI that contains the game UI, and then we have the PhiloAgents API. All right, and this is in itself a Python project. All right, you can see here that has the PyProject YAML. It has a Docker file if you want to containerize all this Python project, the env example, Docker ignore, and notebooks, the data that we need for the evaluation dataset. And here inside the source PhiloAgents, you have the proper application, the proper PhiloAgents application, and it's structured with using clean architecture. Okay, you can see here the application layer, the domain layer, and the infrastructure layer. But of course, I will cover each one of the components of these three layers in later lessons. All right, so don't bother about it. In this lesson, I just want to be brief and just show you how to set up everything to have this running on your local laptop. So to start using PhiloAgents, you will need to go to this install and usage markdown that contains basically what we need. So let me show you how you can do it. Okay, let's close down the original one and let's get started. So here in the install and usage, you have all the prerequisites that you need, like UV, the version of Python, Git, Docker, okay, things that I assume you already have on your local machine. And if you keep scrolling down, you will see all the different steps that you need to take to have PhiloAgents running on your local laptop. Okay, so we have already cloned the repository. Oops, sorry for that. We have already cloned, as I was saying, the repository. And what we need to do now, let's open a terminal. What we need to do now is to get into the PhiloAgents API, all right? Inside this API, inside this folder, we are going to create, first of all, a virtual environment, all right? You can do it like this, and we are creating a virtual environment just inside here, all right? The PhiloAgents API folder. After that, we are just activating this virtual environment. We can do it with source.env thing activate, and you can see that the virtual environment is already activated. And after that, we are just going to install all the dependencies, all right, which are quite a few for this project. All right, so we are installing everything that is needed for PhiloAgents to run, and lastly, we are just going to run this this command to test that we have Python 3.11. All right, so uv run, and now Python, and we are going to check the version, and after a bit, we will see that yeah, the Python version install is 3.11.9. So now it's time to take the environment to set the environment variables. Okay, and to do that, we just need to copy the env example that we have provided in the repo and just create another env with the proper environment variables that we need. All right, if we go inside, you will see that we just need 3 of them for this to work. We need the Grok API key, we need the OpenAI API key. This is necessary for module 5 because OPIC works with OpenAI, just with OpenAI, and that's the reason why we needed this. And lastly, the Comet API key, all right? You might be asking, why don't we need, for example, all the connections with MongoDB? Because if we run this locally, and that's my aim in this first lesson, you don't need any connection, any password, anything to get the connection with the remote Atlas service, all right? I will leave you a couple of minutes to take all the relevant environment variables and to put them in the .env file, and after that I will show you how to start the PhiloAgents project. Okay, so if you have everything installed, it's time to start PhiloAgents on your local machine. Okay, so you need to go to the previous to the parent folder and then just run make infrastructure app, all right? That is going to start the 3 services that we need for PhiloAgents to run, all right? By the way, if you go to the Docker Compose, you will see the 3 services that I'm referring to. First of all, we need this local dev atlas, the MongoDB database for both the short-term memory and the long-term memory. Then we have the API, that is the agentic backend. And lastly, the UI that contains the game UI that is going to start the phaser application that we have defined inside PhiloAgents UI. And now this Docker Compose is going to run. And if we go, in fact, to Docker Desktop, you should see here like the containers spinning up in a few seconds. So let's see how it goes. It's going with the API, creating the API backend. All right, so here it is, PhiloAgents course application, and it contains the 3 services that I was telling you about: PhiloAgents UI, the MongoDB database, and lastly the PhiloAgents API. Okay, so since this is just an overview video, I'm just going to show you how to interact with the video game itself. So just click, let's go to localhost 8080, and you should see something like this. This is the PhiloAgents UI. So you have 3 options. First of all, you have these instructions: arrow keys for moving, space for talking to the philosophers, and escape for closing the dialogue when you're speaking with one of the philosophers. Of course, you can go to support us by giving a star to our project. And then we have the let's play button, which I think is the interesting one, right? So let's play, and you can move Sophia with the arrow keys. I tried to give the philosophers some kind of historical coherence. So first of all, you'll have the Greek philosophers, Socrates, Plato, and Aristotle. For example, here, hello, who are you? And you can talk with whoever philosopher you want. So I am Plato, seeker of truth and wisdom. I invite you to join me on the journey through the realms of thought. So very boring, Plato. Here we have Aristotle in that garden. Here is Descartes. Hey, what do you think of the phrase, I think, therefore I am? Sorry, I'm a bit nerd with philosophy, as you can see. So, bonjour, I am René Descartes. That phrase, je pense donc je suis, my French is terrible, is my own conclusion I reach after doubting everything, even my own existence. But tell me, can you truly think? So here, for example, that I'm asking about specific ideas or philosophies of the specific philosopher of Descartes, in this case, it's going to use the tool to provide relevant context from the rack system, all right? Okay, we keep walking through the village, and you see here Leibniz and also Ada Lovelace. Here we have John Searle and the famous Turing here. So, hey, what is a Turing machine? Alan Turing. A Turing machine is a mathematical model for computation, a simple device that reads and writes symbols on an infinite tape, helping us understand the limits of computation and decide a machine can truly think. That's beautiful. So, can a machine fool you into thinking it's human? I don't know. Okay, you can see how you can interact with all of these philosophers. They are going to start asking you about different topics, about what is consciousness, what is AI, the ethics of AI, etc. Depending on each one of the philosophers, the topics are going to be very different. All right, so here we have Turing, Dennett, Chomsky, Noam Chomsky, and lastly, two great philosophers from the 21st century, Miguel and Paul. All right, and you can talk to both of us. So hey, we will always give you the same answer. So hey there, I'm Miguel, but you can call me Mr. Agent. I love to chat, but I'm currently writing my Substack article for tomorrow. If you're curious about my work, take a look at the neural maze. And the same goes with Paul here. Yo. Hey, I'm busy teaching my cat AI with my latest course. I can talk right now. Check out the coding mail for more of my thoughts. Okay, so just a funny Easter egg in the video game. All right, and this is everything for today. I hope you enjoy playing with PhiloAgent simulation. And yeah, let me know in the comments what you think about it. Next week, we will cover how to create these AI-powered NPCs using LangGraph workflows. And until that time, happy coding.